So I've got another function here for us to look at, another rational function. And we're going to see if we can sketch the graph of this thing. And to do that, I'm going to follow this same four-step process. Right, I'm going to start by finding the domain of the function. To do that, we're going to take that polynomial that's in the denominator, that's the x cubed minus 9x, and I'm going to kind of set that not equal to 0, right? Because I'm looking for the points that I'm going to have to exclude from the domain. So I'm going to pull an x out of that. I'm going to factor it, right? If I take an x out, it becomes x times x squared minus 9. And x squared minus 9, that's the difference of two squares. So I can factor that further, and this turns into x times x plus 3 times x minus 3. So that's going to give me three numbers, right? X equals 0, x equals negative 3, and x equals plus 3 that are not going to be in my function's domain. Okay, so the asymptotes. Before we find the asymptotes, I want to simplify the function. Right? My concern is, since there's so much going on up there, if I just set the denominator equal to 0, I'm going to get those three numbers again, negative 3, 0, and 3. My concern is, what if one of those three factors there cancels out with something in the numerator? Because remember, if that happens, then that factor's number, if you will, isn't going to be an asymptote, it's going to be a whole. Right, so if we factor these, we already factored the denominator. That's x times x plus 3 times x minus 3. The numerator, that's x plus 3 times x minus 1. And yeah, we've got those two x plus 3s. Right, those are going to cancel and leave me with x minus 1 over x times x minus 3. Now I can look at the denominator and get those vertical asymptotes. Right, the x factor there gives me x equals 0. The x minus 3 factor gives me x equals 3. Okay, so how about horizontal asymptotes? Well, now you can look at the simplified version. You can look at the original version. Doesn't matter for this part. You're going to get the same answer either way. The degree of the numerator in the original expression is 2, and the degree of the denominator is 3. The denominator is the greater of the two, so this is going to have a horizontal asymptote at y equals 0. All right, so how about the intercepts? To find the y-intercept, I'm going to calculate f of 0. Right, I'm going to put 0 in for x. If I substitute 0 into that big formula, we get 0 plus 2 times 0 minus 3 over 0 cubed minus 9 times 0. And now something interesting happens here. That simplifies to negative 3 over 0, which is undefined. So what that means in practical terms is there is no y-intercept. Right, so let's move on to the x-intercepts. Now, again, I'm going to work with the simplified version here. Right? The unsimplified version could give me numbers for the x-intercept that actually aren't because the function is undefined there. So it's going to be better if we go to the simplified version. I'm going to set that equal to 0. Multiply through by the denominator, x times x minus 3. This turns into x minus 1 equals 0, which gives me x equals 1 for my x-intercept. So there's only one. Okay, so let's go to the graph here. I've just summarized all the information we have so far over there on the left-hand side. So let's see if we can start putting these pieces into the graph. So first, I'm going to put the asymptotes in. So I've got an asymptote at x equals 0. That's the y-axis. I've got another one at x equals 3. And then we've got the horizontal asymptote at y equals 0. That's the x-axis. Okay, so there's my asymptotes. Now, let's look back at the domain. We don't have to worry about 0 and 3. Right? Those already got handled by the two asymptotes. Negative 3, there's going to be a hole in the graph at that point. And I'm a little bit stuck because I don't know how high or low it's going to be. I don't know exactly where that point is going to end up. I'm not going to know that until I get some more of the graph sketched in. So what I'm going to do, just to kind of remind myself, because this is a common mistake students make, they get so wrapped up in doing the calculations from here down, they forget to circle back to that. So what I'm going to do is I'm going to put a circle here at x equals negative 3. And that's not where it's going to end up, almost certainly not where it's going to end up. But that's just a reminder to me that I'm going to have to get that into the right spot eventually. Okay, So let's put that intercept in there. Let's put 1 comma 0. And okay, that's not a whole lot to go on just yet. So let's take a look at the left-hand side, the stuff to the left of the first vertical asymptote. This is another one of the situations like we saw in the last example. The graph is going to do one of two things. It's going to start off by the asymptote and it's going to come up to the vertical one, or it's going to start below the horizontal asymptote and it's going to go down to the vertical one. Now, I said this something very similar in the last example, and I kind of just, you took my word for it, I guess. But there's a reasonable question to ask here. How do I know that the graph is that nice and neat? How do I know that it's not doing some weird bouncy up and down thing, right? Well, here's how I know that. You notice that my weird bouncy up and down thing crossed the x-axis several times. But I know my graph doesn't do that. My graph only has one x-intercept and is over there in between the two vertical asymptotes, right? So I know that my graph cannot cross the x-axis anywhere in that section. So let's take that out, right? That's my explanation. And to figure out which of these two we're going to keep, I'm just going to plot a point, right? This is step number 4. So keep it simple, right? I need to pick an x value to the left of 0, and so any -1 except -3. Don't pick that one where it's undefined, right? I'm going to pick -1. F of -1 is -1 minus 1 over -1 plus 2, which is -2. Okay, awesome. The graph is below the x-axis at that point, right? That point is down here somewhere. So I'm going to keep the lower section, and I'm going to get rid of the upper section. Okay, so how about what's going on in the middle here? Well, there's really 4 options. The graph could come down, touch that point, turn around and go back up. It could come up, touch that point, turn around and go back down. Or it could go through it, either rising or falling. Okay, if you think back to the factored version, that x-intercept came from the factor of the numerator x minus 1. I'm going to kind of go back to the multiplicity stuff we talked about when we talked about polynomials, right? The multiplicity of that factor is 1. Therefore, the graph passes through that point. The function changes sign. It's going to have one sign on the left side and another side on the right side. So I know the function is going to either start low, go through that point, and keep going up, or it's going to start high, go through that point, and keep going low. And to figure out which one, I'm going to grab another point. Right? I'm going to do f of 2. F of 2, you can substitute it in there, do the arithmetic yourself. That comes out to 1/4. Excellent. That's positive. It's right about there somewhere. We're sketching. This is not going to be perfect. So now I know what my graph does in that section. It starts low, comes up through those 2 points, because it makes a pretty sharp turn in there, and then heads up towards the asymptote, which, remember, vertical asymptotes, the graph of a rational function will never cross. All right, now I got the same situation going on the left-hand side. Excuse me, in the right-hand section. It's either going to start up high, drop down and level off at the asymptote, or start down low, come up and level off towards the asymptote. To figure out which one it's going to do, I'm going to look at another point, right? If we look at, let's say, f of 4, that's 1/2, which is positive. The graph is going to be above the x-axis in that section. So this is almost what our graph looks like. We got one more point we got to circle back to. All right, we got to circle back to that empty circle there and get in the right place. Now I know where it goes. Right? I'm going to take that empty circle, I'm going to remove it, my reminder, and I'm going to put it back in down on the graph at x equals 3. I don't know exactly what the y part of the coordinate is, and I don't care. Right? I know that x equals -3 is the correct spot. Okay, so that's a more complicated example, right? There was quite a few things going on there. In the next lecture, we're going to look at one more of these where we look at a situation that's complicated for another reason. We're going to look at a situation where we actually don't have a lot of information and see how we can infer what that kind of graph is going to look like.